pen mystery. You have some tape to fix my thingy. I know I'm demanding a lot.
So,
right
table H needs to be out. Oh, you said pen?
Yeah, pencils give me goosebumps. They make my, like when I write the texture of it, it's just like, gives me,
I know, I hate that.
Gives me the heebie-jeebies.
Table H should be out, and your homework should be out.
You didn't do it?
I'm a fast furious over this.
Me?
Table H. Hello. Yeah. Yep. Alright, fine. Shelby, down to the office and grab something quick. Okay. So again, table H should be out and your homework should be out. And you are attempting to answer this question, but this is going to be kind of hard. It's a very hard question. I'm going to walk around, check your homework. When I come back up, I'm actually going to erase this, and I'm going to use the Vimeo to put table H on the board, and we'll try and explain this together. And I want you to have some sort of thought. You got a demo today at the end of the class, which is kind of a cool demo.
That's easy. The higher the pressure, the stronger track. Yeah. Push that back. Boom. Right there. Stronger. Oh, is this one's stronger?
So we figure this out. So you think you're alright with that? I guess we'll find out, right? Okay, first let me give you credit here and then we will go over this. So you, again, table H should be out. You're thinking about what's going on here. So just Kristen, right? Okay, you guys are usually real good with the homework. Some of you forgot. It's not the end of the world. Just make sure you do it, all right? And you get half credit for that. Show me tomorrow.
As soon as I got out of school, I went home from 3:30, 3:30 to 8, and then I got home.
Okay.
I was tired as shit.
Does anyone have any concept of the answer here?
On the weekends,
Any concepts? Hey. Alan, got anything for me? What's the first problem with me asking you this question?
You didn't teach us.
I didn't really teach you what vapor pressure means. So,
Do you want me to record it?
this should be recording already.
How do you tell?
Is the thing blinking? The red thing? Is it blinking?
Don't touch anything.
Yeah, it is blinking.
Okay. Alright. So, how can we use table H to figure out how vapor pressure is related to the strength of the force of attraction? There's nothing on this chart that says forces of attraction. But we talked about something yesterday. What on this chart lets us know the force of attraction of these four liquids? Boiling point. Where on this graph can we figure out, or where does it show the boiling points of the four liquids? Who remembers from yesterday? Where on this chart can we look up the boiling points of these four liquids? What's that?
The line
What line?
in the middle.
Be more specific, there's a lot of lines.
The intersecting.
These are intersecting lines.
No, the dotted one.
Thank you. That's what I wanted to say.
Sorry.
The dotted line. When the solid lines here, propanone, ethanol, water, ethanoic acid, you can look at yours or up here, it doesn't matter. I want to show you how to read it though. These four curves, when they cross the dotted line, that's when they boil. That's their boiling point. How do I know that? Water is 100. That's how I know. What about ethanoic acid? What's that boiling point right there? Who can read that? Read that graph. Right here. What is that boiling point down here? About 117, okay? Because this line is 120 and it's maybe right there. So that's about 117, 118. What's the boiling point right here? Ethanol. About. What's that one going to be? Jake, you with me? Stay with me. Somebody, come on. Yell it out. I don't care. What's this? What's the boiling point right here? What is that?
80.
About 80. It's right here. Okay, about 80. What about propanone? What's the boiling point when it crosses that dotted line? You can look at your own. You don't have to look up here. What about Jenny? What is that boiling point for propanone?
55.
About 55. Yeah, it's right about there. So we have 55, we have 80, and we have 118, let's say. And we have 100. So, propanone boils at 55. Ethanol boils at 80. Water boils at 100. Ethanoic acid boils at 118. You may not know what these things are. You know what water is. You may not know what the other three are, but that's irrelevant. All four of them are liquids. They boil at different temperatures. What does that tell us? Tell me. What information does this tell me about the four liquids? That relates to the question I wrote on the board.
What's the question?
Question on the board, let me repeat that, said, what's the relationship between vapor pressure and the strength of the forces of attraction in the liquid? That was the question I wrote on the board.
Some of them are weaker and some of them are strong.
Right. How does this boiling point help us figure out which one is stronger or weaker?
Because the higher the temperature, the stronger they are.
Very good. The higher the boiling point, that's the last thing or the only thing we really wrote down yesterday. The higher the boiling point, so ethanoic acid has the strongest forces of attraction. The lower the boiling point, the weakest forces of attraction. So propanone, this line right here, that liquid has the weakest forces because it takes less energy to boil. It's not as hot. Ethanoic acid takes almost twice as much heat. Right? Actually more than twice. What am I saying? More than twice. More than twice the temperature, right? So that's a lot more heat. So it takes more heat to boil ethanoic acid. So ethanoic acid has the strongest forces. Propanone, weakest. Again, the boiling point tells us that. Hopefully that makes some sense. Questions on that before I answer the question I wrote on the board? So Evan, water or ethanol? Water, ethanol. Which one is stronger? Water. Why? Higher boiling point. Very good. Okay, so that's how we read this chart in terms of boiling point and strength of the forces of attraction. Okay, back to the question I wrote on the board. What's the relationship between vapor pressure and the strength of the forces of attraction? We know this one is the weakest, right? That's the weakest. That one's the weakest. We know this one is the strongest. Strongest. We know that. So what's the relationship between vapor pressure and the forces of attraction? Vapor pressure is on the y-axis.
Is it the lower the vapor pressure, the higher the, or the stronger the bonds?
Forces.
Forces?
So the lower the vapor pressure, the stronger the forces.
Yeah, I think so. I think that's what I'm trying to say.
So if we look at the y-axis, where would low vapor pressure be? Down here near 0 or up top near 200?
Well, obviously down near 0. Lower.
It's not so obvious to everybody. But yeah, down here would be low vapor pressure, right? You're correct.
Yeah.
I agree. Good job. Low vapor pressure here. So this would be low. And then up here would be high vapor pressure. Everyone agree with that? Okay. Someone pick a random temperature on the x-axis. We're going to have to figure out if Ryan's right. We're going to prove it. We're not going to say yes. I'm not going to say yes or no. We're going to prove it. Someone pick a random temperature up here.
118.
118. Okay. 118. Let's not use that. Pick a temperature under
73.
70. Under 70. Sorry.
49.
How about we just pick 55?
69.
Yeah, because it's already labeled. So, here's 55. Stay with me. At 55 degrees, what is the vapor pressure of ethanoic acid?
10.
About.
10.
Right here, right? Does that make sense to you? That's
Yes.
ethanoic acid's vapor pressure at that temperature. What about propanone? What's the vapor pressure?
High.
About 100. So Ryan said low vapor pressure means strong forces of attraction. High vapor pressure means weak forces. According to what we just did, is he right? Yes, he's right. Very good, Ryan.
Of course I'm right.
So, all right, easy. So what we're going to talk about today is boiling, vapor pressure, and then the demo at the end kind of explains vapor pressure, shows you a little example of the vapor pressure. So I started with the chart because this is kind of a culmination of everything we're going to learn mostly tomorrow and Friday and Monday. Today we're going to go over the homework a little bit and then take some notes, but we're not going to get through a whole lot today. But it's all about vapor pressure and boiling points and how it all relates. So what do I want you to take away from this? One, how to read this thing. Okay, we're going to practice more with that. And two, actually three things. Two, how to find boiling points, which we did. And then the third thing is how vapor pressure relates to those boiling points. Notice how propanone is always higher. The line is always going to be higher. No matter what temperature you pick, it's always higher. How come I didn't like Jake's 118?
Because
I said it.
Why? No, not
because it doesn't really prove it because it's kind of high.
I can't read this graph for propanone at 118.
Yeah.
I can't go, if I go all the way up to 118, propanone stops. So I can't, so that was a hard example.
What do you mean it stops?
Look at the top of the graph. I can't reach, but it's,
Would it still be going up?
right, but it starts to, it does this, essentially. So 118 was
Well, it
over
starts
here. You're
curving
never going to
backwards.
reach it. The vapor pressure is way too high at 118
What do you mean?
because it's not a liquid anymore, it's a gas.
So the vapor pressure.
The vapor pressure, so propanone's
Gotcha.
vapor
Okay,
pressure
no,
at
no,
118,
Yeah, no.
it's so high.
I'm really
it can't-
tired and I'm just confusing myself. Just
Okay.
thinking too hard.
Anyways, that's what I wanted to take away. Is that question was really, really hard. Higher vapor pressure means weaker forces. Remember, try and remember that. At the end of class, it'll make a little more sense if it doesn't already. All right, homework. Let's go over the homework. I'm going to read the answers, all of them, and then I will go over 2 of the problems. That's it, just 2. So we got to move on. Your quiz Friday, you will have to do problems like this. So hopefully you're okay with it by the end here. 451, number 18. The answer is, and I forgot to mention yesterday, or not yesterday, but I guess I just forgot to mention in general. What 2 units for pressure do we know of right now?
Oh,
Yeah.
ACM and KPA.
Right, ATM, KPA. Kilopascal and ATM. Okay? Another one is torr, which is torrents, short for torrents. And another one is millimeters of mercury. You will never see those on a test or quiz from me or on the regents. The book uses them because they're useful in real life. Places, instrumentation, they use those. Not always this. Kind of like tire pressure on cars or trucks is PSI. It's just a different unit. These are different units, okay, but it's all pressure. So I forgot to mention this. You might have been a little confused. This stands for torrents. That's millimeters of mercury. Barometers. You guys know what barometer is?
Yeah.
It's air pressure. Usually has mercury in it. That's how they measure it, millimeters of mercury. So that's a unit. So you might see that sometimes too. I just forgot to mention that in our pressure conversations. 18, 711, 711 torr. That's the answer. 711 torr. Moving on. 468. Go to 468. Where's your book? You gotta have a book. In case I want to say, all right, everyone look at this question. I want to talk about something. You need to have it.
I appreciate it.
I got your own. Thank you.
So you're getting yours out?
Yeah.
Okay.
Yeah, you should start school later because I'm done with not getting enough sleep. I'm just not going to school starting out.
Okay.
I'm not going to school.
Number 50 or 60, what are we doing?
56.
What page?
You
468.
should start school at
56, here we go. 5.91 times 10 to the 4th. 5.91 times 10 to the 4th liters. I'm going to go over that one. 57A, 1.6 ATM. 1.6 ATM. 57B, 186K Kelvin. But if you round it to the sig fig rules, it's only 200K. I'll explain that. 57C, 508.8 millimeters of mercury, mmHg. Or if you round it using sig fig rules, 510 mmHg. 58, 2.68 liters. 2.68 liters at 3 sig figs. Number 59, 1.17 ATM. That's 3 sig figs. 60, 74.8 kPa. 74.8 kPa. 3 sig figs. Alright, I'm going to go over 56. Is there another one we want to go over besides 56?
60.
Alright, I'm going to go over 56 and 60. If there's another one you're confused about, hopefully when I go over those two, it'll help you understand what you did wrong. If you maybe didn't convert to Kelvin, some of you, if you made a mistake, that could be a mistake. Got to convert to Kelvin. Alright, so for 56, when you read 56, it says a weather balloon is filled with helium that occupies a volume of 5.00 times 10 to the 4th. That's my V1. So V1 is 5.00 times 10 to the 4th liters. That's my V1. Then it says at 0.995 ATM. That's my P1. 0.995 ATM. The temperature is 32. We got to convert that to Kelvin. What is that? What's 32 in Kelvin? Number 56. Somebody probably did this. I mean, not probably. A lot of you should know this. What was it? Sorry. 305.
Yeah.
305 equals. Now, question 56 continues. Says it releases the balloon. It rises to a location where pressure is 0.720 ATM. 0.720 ATM. And the temperature is negative 12. What's that in Kelvin? Negative 12. 261. Good. It says find the new volume. Find the new volume. That's the setup for 56. Ryan, you with me?
Yeah.
Pay attention. And I don't want that back since you're making
You can get the pen
lunch
back.
out of it.
I know, I'm sorry.
So, this is the setup for 56. Now what do? Let's go through it kind of slow here. What's the next thing we do to solve for x? Multiply what? These two numbers here. 0.995 times 5 times 10 to the 4th. You multiply them, then what? I'm not going to write that down.
Multiply it times 2.
Then you multiply it by 261. So multiply these three numbers. Does anyone have that number? I can write it down.
Yeah.
It's like 12 million something.
1298475.
1298.
4750. I think that's right.
Seems high, right? Is that right? Xavier says it's right. Okay.
12 million, man. That's how much money I'm gonna make in one day when I'm older.
Pay attention first. So 0.720 times 305. Who has that number for me? You got that too? 0.72 times 305?
The what?
this times this.
219.6.
219.6 times x. So now we solve for x by dividing by 219.6. That kills that. Divide by 219.6. And x equals a big number.
59,000.
59129
liters.
And that's liters. However, 3 sig figs is the rule. Why? 3 here, 3 here, 3 here, 3 here, and 3 here. So I need to round that to 3 sig figs. So you can leave it 59100, but that's I mean, I guess you could do that. You could just write that. That's your final answer. Or scientific notation just looks better. But they're both literally the same answer. Both of those are the same answer. 3 sig figs here, 3 sig figs here. You just gotta get rid of that 29. 60. Now your quiz Friday, I think I started to tell you what was on it and then I changed my topic there. So let me do that first. But 60 is a good example of a short answer you're going to see on Friday. I put the quiz together yesterday. 15 questions. I want to say 11 or 12 multiple choice, 3 or 4 short answers. You're going to have to do this stuff 3 times. Okay, 2 short answers like this, and then 1 multiple choice. There's 2 questions about liquids, which we're going to talk more about today and tomorrow. Just 2 questions. And then the rest of it's going to be general gas questions. I don't want to be too specific, but how gas particles move, properties of gases, kinetic molecular theory, if they collide, what happens to the energy, stuff like that. Temperature conversion, Kelvin, Celsius. Definition of temperature, you need to know that. Kinetic energy's on there. Questions about kinetic energy. That's about it. It's only 15 questions, so it's not.
Although the definition of temperature is the heat particles in the air, something like that, right?
No, the word heat's not in it.
And what is it? Can we go over it real quick?
Yeah.
The
Measure of
the movement of
the
particles.
average kinetic energy.
Oh, the average
That's
kinetic energy.
measure of the average kinetic energy.
Alright, cool.
That's the reason I put that on, and you'll see that question again. Is it's a pretty common Regents question. All right. So everyone, look at the picture on page 468, number 60. Notice how we have the smaller flask, volume of 500, pressure is 108, temperature is 10, and then the bigger flask, you have a larger volume, 750, temperature is also increased. So we would expect that the pressure would probably go up because the temperature is increased, but maybe go down because the volume is increased, right? So which one's going to affect it? We don't know. That's why we plug it in the equation and figure it out. Turns out the answer is what? 74.8. So the pressure goes down. Well, we got to show how to get that answer. So here's how we do it. They give you all the numbers. You just got to set it up. 108 times 500 divided by 283. You got to convert 10 degrees Celsius into Kelvin. Now V2 is 750. X goes for P2. That's 750. And the temperature is what? 21. So what is that? 295? Yes?
For what one?
Yes. 295.
I got 294.
It's 4. My bad. It's 3 and 1. 294. Same thing as last problem now. Multiply these two. Multiply 294 by those two. So who has that number for me? All 3 of them multiply. Go ahead.
15876,000. I don't know if that's right.
Anybody
Is that
want
what
to
you got?
confirm?
Okay.
Yeah? Okay. 283 times 750. Right?
It's like crammed. I can't. 2122508. I think. It's like crammed on the side of paper. 1222508. I believe. Is that right? Anyone else get that?
Edmund?
Another 0 at the end of no, not that one. That one.
Oh.
What about this one? No?
No.
Okay.
Thanks, guys.
Sorry.
250.
250?
212.
There was no 8.
212.
Oh, there's no 8
Well,
there?
his was pretty much right, except for the 8.
I need more numbers. I don't know.
250 on that.
Oh, 250.
Oh, so there was no 0? Oh, that's a... What is that? What the hell did I write?
Oh, wait.
Alright, I
Keep
got
it
really
clean for the
confused.
camera over there.
What?
Keep it clean for the camera.
I didn't say anything right, did I? said hell.
You said hell.
I say HE double hockey sticks next time.
There you go.
Alright.
Divide those, that's your answer, and it's whatever I said, 74.8. So that's how you do number 60. 74.8 74.8 kPa. So I hope you feel pretty comfortable doing that. You're going to have to show me you know how on Friday's quiz. No more questions. Alright, take out your notes for a little bit, then we'll do that demo.
Oh, what are we doing for the demo?
Notes first. Notes first.
No. Nah.
Yeah.
Tired.
No one's witnessing this weird behavior? What just happened?
What?
Are you gonna race that? You gotta use the race. Oh, we're gonna have the big guns.
Say it again?
Biggest.
No, it's the eraser bent backwards.
What? And backwards.
What do you need?
Yeah, you had to like clap them, right?
No, just put the top in the like in the block eraser.
When I was in elementary school, we had to
Alright, so yesterday, alright, focus, yesterday, you're looking at your notes, I'm going to review what we did yesterday. We wrote down that the boiling point of a liquid tells us how strong the forces of attraction are. Low boiling point means weak forces of attraction. High boiling point means strong forces. Why? Because more energy is needed at that higher boiling point to break the particles free. Because that's what happens. You go from a liquid, close together, break apart as a gas when it boils, so it needs more energy. That means it has higher or stronger forces. That's where we left off. We need to define what the heck boiling point is. So we're going to define boiling point. Give yourself 2 or 3 spaces. Then write normal boiling point. So put normal in quotes. We got boiling point, we got normal boiling point. We have to explain and define both of them. Then we're going to define what vapor pressure is. And then we kind of have enough information where we can do the first demo. We have another demo that I'll probably show tomorrow. I don't know, we have a little bit of time, but we'll see. Also, you don't have any homework written up there, so that means no homework for tomorrow. But I'll probably just have you do it for Friday, even though I know you have a quiz. Okay, does anyone think they know what boiling point is?
when it changes from a water to a gas.
Changes from a water.
A liquid, my
So
bad.
water from a liquid. I knew what you meant. From a liquid to a gas. So how's it different than evaporating?
Because this one, it's evaporating, like can happen at any temperature, but boiling point is like faster. So,
Faster?
When
Huh?
the liquid particles are heated up enough so the forces of attraction
are broken.
That was from them moving around.
Good. So when liquids
Water.
boil,
The
they
water-
gain energy. The particles gain enough energy to break those forces, and that's called the boiling point. Very good. That's exactly what happens when something boils, but it's not the definition. Very good, though. That's
Alright.
very good. Remember that. That's important.
water bubbles.
The definition has no. Close the book. Close the book.
I won't say
Close
it
the
out loud.
book. Close the book.
I need to know.
Close the book. Close the book.
I need to find it.
Okay, put the book behind you. Behind you. On the desk behind you. There you go. Okay, boiling point has nothing to do with heat. Boiling point has nothing to do with heat. Boiling has nothing to do with heat.
Wait, can't you boil stuff?
I'm going to boil water in this room
Without-
probably next week without giving it any heat at all.
I know how to do that.
How?
Your hands and magic.
Magic, right?
Yeah.
Okay. I know one person in here knows, I think, but we're not going to put her on the spot right now. Boiling point. Here's the concept. You have water. Here's a water.
Okay.
Here's an air. Okay.
Nice.
So you have water with a certain force pushing up against the air, and the air has a certain force pushing down against the water. most of the time, who wins that battle?
Air.
Water pushing up or air pushing down?
Air.
I'll give you a hint. The oceans exist.
It's the air.
I'm going to give you another hint.
Equilibrium.
When the force of the water pushing against the air wins, water evaporates.
Maybe sharks.
So it's like an equilibrium kind of. It's like sometimes.
So which one must be stronger?
Air.
Air.
Obviously.
If I dump this water on the floor, it will not evaporate instantly. It will take a while. That's because air's force pushing down is keeping the water together. Water pushing back isn't strong enough until it gains energy. This is what Jake was talking about. Until it gains energy somehow, then the particles can push back and they will evaporate. What's this force called?
Gravity. Darn.
Pressure.
Air pressure. Very good. This is air pressure. What's this called? Talked about it first 10 minutes of class.
Water pressure.
No. Oh,
Vapor pressure.
Vapor
Yeah,
pressure.
that's what I
Right.
say that. Yo.
Vapor pressure. So there's vapor pressure and air pressure. Most of the time, air pressure is winning that battle. But as soon as water equals the air pressure, guess what it does? As soon as the vapor pressure equals the air pressure.
It wins and it evaporates.
Boils.
Boils. That's the definition of boiling.
That whole
That's
big
the
thing,
definition.
that's the definition.
The definition of boiling point. The temperature at which a liquid's vapor pressure equals the air pressure. I'll finish that when I get back. Ella. Which one? Yeah, sure. Alright. Shelby. You gotta go down and see, well, I want to say her name right. Miss Klein-Klaus.
Bring my stuff.
Yeah, probably. Or Klein-Klaus. Alright, temperature at which a liquid's vapor pressure equals the air pressure. So when these two, so you kept talking about equilibrium, you weren't too far off. When they actually reach an equilibrium is when it starts to boil.
Okay.
So when this is pushing and that's pushing at the same rate.
So I know what you're gonna do.
So that's what happens when something boils. Nothing about heat. So what am I going to do?
You're gonna cool the air pressure down to water pressure.
Well,
You
cool the
cool
air
the
pressure.
cool the air down with the
Stop
water.
saying cool. That's heat.
What?
Temperature and pressure are two different things. I'm not going to cool the air down.
But that. So
Gonna
you
lower
just,
the pressure.
Right.
the air pressure.
I'm going to lower the
That's
air
what I
pressure.
meant to
I
say.
know that's what you meant. I want to make sure you say it right, though. So lower the air pressure. Yes, very good. Good job.
I know how
lower
he's
the
gonna
air
do-
pressure.
he's gonna do it backwards.
So I'm gonna show you that.
You just start
What is
pumping.
normal boiling point? Here's what it is. It's the same definition. It's the boiling point. So it's the same definition as this one. The boiling point at standard pressure. At standard pressure. So what is standard pressure? Someone give me
STP.
one of them. Someone besides Ryan. Steph. 101.3 kPa and Shelby. 1 ATM.
Actually, I remember one.
Yeah, I gotta get other people talking, but I can't just have the same people talking. So, the boiling point at standard pressure is 101.3 kPa or 1 ATM. So, in this room, water's normal boiling point is 100. But, if we go somewhere else in the world,
Space.
That's not in the
world. So Earth. Then this
Universal
applies.
Studios. is the
Okay?
closest thing.
This applies. Boiling point's only when the air pressure are these numbers. If we're anywhere else, it's technically not normal. It's just called boiling point. All right.
The Universal Studios.
We're gonna come back to that. Shh, stop mumbling. We're gonna come back to these, but it's important to know the definition first before we go further. So now what we need to do is define vapor pressure. Then we'll go back. Do the demo. Okay. So vapor pressure. This little diagram doesn't really help too much to understand it, but it's a decent concept. So You gotta define it. But you guys already know the answer to this. What is vapor pressure? Blake, what's air pressure? What causes air pressure? Stop looking. Shh. If you don't know, it's okay. If you forget, it's okay. Bree, what causes air pressure? Yeah, but I need something else. It's okay. Devin. Air particles doing what? Colliding. That's all that causes pressure. Air particles colliding with each other, with the walls of their container. Okay? That's air pressure. What causes gas pressure? Gas particles colliding. What causes vapor pressure?
Vapor particles colliding.
Vapor particles colliding.
Wow.
Vapor particles colliding. With a certain amount of force, right? More force to the collisions means more vapor pressure. Less force means less vapor pressure. I'm going to add one more thing, then we're going to go back. Liquids with high vapor pressure have, sorry, that's a really bad cue. Liquids with high vapor pressure have weak forces of attraction. We already talked about that in the beginning of class. But now is the time to write it down. And the demo is going to show that. Liquids with high vapor pressure have weak forces of attraction. I'm actually going to do this demo twice. I'm going to do it right now, then I'm going to do it again tomorrow, just to make sure we really understand what we're seeing. Okay, so once you get that done, or down and copied, go grab glasses, meet me at this front table.